Any luck, TJ? Can you hear us?
I can hear you now. Thank you.
Okay, good. We're set then. Okay. So thank you. This is Paul Dahl, and I'm the chair of the IEEE Southern Minnesota section, and we have a speaker tonight that is going to talk about Docker, TJ Maines. And TJ graduated with a BS in computer science from the University of South Florida
Yes,
in
sir.
2015. Upon graduating, he went to a position as a software engineer with Rejuvenan Global Health. Did I pronounce that right?
Yes.
Not really. And then
Rejuvenan. Yeah.
Rejuvenan, and then software engineer 2 with NBC Universal Media. He later moved on to his current position as a senior software engineer with Pivotal, which was later acquired by VMware. His responsibilities relate to building and managing web applications, iOS and Android, as well as consulting in the design, development, and delivery of software solutions using test-driven development, pair programming, and lead product development. TJ is extremely passionate about software development, but he also enjoys coffee, photography, and time with his dog. So thank you, TJ, for being here, and take it away.
Yeah, thank you, Paul. All right, let me share away. Awesome. You can see my screen?
Yes, we can.
Awesome. Welcome, folks, to my introduction to Docker talk. As Paul said, I am TJ Maines, and it's great to have everyone here tonight. It is kind of a special day. It is 2/22/22, like 02/22/2022. It's a Tuesday. It's amazing. What a day to be living. So, yeah, I'm TJ Maines, and as Paul said, I'm a software engineer at VMware Tanzu Labs. I do a lot of consulting. I do quite a bit of app development. I also do kind of a lot of like coaching and kind of like team building type of exercises. And I really enjoy automating the hard things, which is why I really enjoy using Docker. So, yeah. And if you'd like to find out more, you can always look at tjmaines.com/about. So, but yeah, but I'm excited to be here today, and thank you for having me. So appreciate it. Yeah, so let's jump into it. So what is Docker? Well, Docker is a software platform for building, running, and maintaining containerized applications. Docker has been in production by many major companies. Like you think it, you name it, like they're probably using Docker behind the scenes. Well, at least since 2014. Yeah, so Docker containers have completely changed how high-performing software teams deliver software. And there's that word again, containers. What is a container? Like, we hear the word container often, but like, what's whenever we talk about Docker, we tend to say container like afterwards. So a container is a standard unit of software that contains all dependencies required for an application to run in a tiny, lightweight virtual machine. So for many years, we use virtual machines and operating systems to run applications on, and sometimes our applications were so specialized that they had so much insight into the system that they were running on, which has led to many different anti-patterns and many different like issues that have came up in the industry when it comes to maintaining applications at scale. So containers is a way to kind of package and manage an application in a cloud native environment or right on your local like workstation. So some containerized applications available on Docker Hub also include Nginx. Nginx is a very popular web server. Think of it as like Apache. If you hear Apache, another popular web server technology is also available as a Docker container that you can pull right onto your Windows or Mac OS or Linux-based operating system. Postgres, MySQL, WordPress, the popular blogging platform, Redis, very popular caching solution, and even Python could be run from inside a Docker container, and many more. And so if you take a look at hub.docker.com, you can see all the different applications that are available for you that you can pull down as a Docker image running on your host machine. And so these kind of containerized applications, all you need is Docker to be installed on your host operating system, and you can run each and every one of these applications independently of each other, given you have a sufficient CPU and enough memory to run each one of these programs. But you'd be surprised at how Docker can run on just about anything, including Raspberry Pis, which are very, very resource intensive. But for like IoT or Internet of Things like workloads that run on like teeny tiny devices that are resource constrained, there have been plenty of people and companies that have built and delivered software with Docker on these platforms as well, or on these like hardware, on these like resource constrained hardware. So yeah, so before we go on to talk more about different use cases and how Docker is used in production, we should go over just a brief history of software delivery, kind of like since the beginning. So in traditional software delivery, I would say between 1970 and the early 2000s, software development was very much built on top of mainframes, and then eventually, which mainframes are just essentially specialized hardware running specialized operating systems with applications that were built to work on top of these specialized machines, which worked really well for banks and military institutions for various reasons. Some companies such as IBM and many banks and insurance companies still use mainframe computers, and and some of those machines and systems have been in place for the last 30 years. So I've actually had the pleasure of working with them, which it's always an interesting it's always an interesting time to be kind of like logging into what looks like a POS system or a point of sale system and kind of like learning maybe a language or learning a program that was written 30 years ago and how it works today and how well it works today. So anyways, traditional software deployment was expensive because you had these specialized applications that only really ran on these like special operating systems on top of the special hardware. And so for many years it was like that. But then over the course of like the 1980s and 1990s, open source software development, Linux in the early 90s, and kind of like other factors at play, very specifically like how expensive it was for these specialized machines to be maintained and run by people with very specific jobs for maintaining those applications. General purpose computing became more of a normal thing, especially with like programming languages like Java and Python and eventually like Ruby and JavaScript. And so traditional software deployment, it was pretty expensive, and and if you can think of like the big server rooms of back in the day where there was racks and racks of machines that and with one computer terminal that could operate all these different machines all at once, and they had to be time shared. And so but nowadays, at least between like the early 2000s and about 2010, virtualized deployments started to appear, where you still had your hardware. It could be special purpose. The operating system could be special purpose as well for that hardware. However, the hypervisor or the virtualization kind of era began, where you would kind of take more, whereas you would to reduce the amount of waste that was occurring on these big machines, and software developers built tools that allowed them to kind of bundle their applications and multiple operating systems. So instead of only having those applications running, on that specialized software that could only work on specialized hardware, instead they took things kind of an abstraction above that and allowed general purpose operating systems like Linux or Windows. And it enabled developers to build software specifically for those systems, and it worked. It worked really well for quite a few years. However, even that came at a cost, and the cost was that the operating systems were just there's bundling your application to run alongside another application inside the same operating system came at a cost, and that cost was in terms of maintainability, security, networking. And that was, again, another person's a whole IT department that would be dedicated towards just helping software developers deliver software. And there was friction there as well. And so now in this new era, this newer the cloud 2.0, so to speak, of containers allows you to deliver your application with everything that it needs to run inside of a single container. And as long as you had a container runtime like Docker, then you could bundle and run your application across many different machines, and without having to worry too much about maintaining the security and networking of the machine itself. And so you still have to worry about these things, but because of how lightweight containers are, you don't have to spend nearly as much time focused on all these IT operational things as a software developer. And instead, you could just focus on delivering great features and great products to your end users. So more consistent operations. So software developers could share software between each other on different machines. So whether it was in the cloud on a virtual machine somewhere, or on a developer's workstation. So on your own machine, could the same application that's running in the cloud could also run locally on your machine, and on a team of software engineers, because generally speaking, we tend to work in numbers, especially if you're working on complex, on a complex application. You gain the ability to run the same application across multiple machines without having to worry about, well, it works on my machine, therefore, it should work in production, or it should work on somebody else's machine. So you don't run into those issues of, your application only being able to work on your machine. So, and also increased portability kind of goes hand in hand, that your application can run in many different environments, and that's fantastic from a maintainability perspective. Also, there's less overhead than virtual machines, which we already talked about. As a virtual machine has many different uses and and you're exposed to a larger attack vector from a security perspective. And if you don't have to think, as an application developer, I shouldn't have to think about these things when I'm trying to deploy my application to production. There's some things I should care about, but there's some things I really should not care about, and that's expensive over time. There's also the reduced server footprint. So instead of having dedicated virtual machines that take up all the CPU and memory and disk space, because those VMs had to run, have to be installed and run on a disk on the hardware that it was that it's running on. Instead, you have a lot more control, fine-tuned control over how your containerized applications run locally and in a cloud environment as well. So, and then, however, production deployments are more involved, but they kind of always have been. But soon we're going to talk about, in a little bit, we'll end up talking more about a very popular uh, container orchestration software, and we'll discuss like how Docker containers are delivered into a production environment using modern tooling. So yeah, lots of theory, well, not just lots of theory, but also lots of like some history. But let's talk through an actual example using PostgreSQL. So PostgreSQL is an open source SQL-based database. It's very popular, especially in the geospatial community, but it's also been used at places like Facebook and well, actually, it's pretty much used in many, many different places. So I just used it as an example database to walk through. So without Docker, if we were installing PostgreSQL, well, it depends on which system you're on. So if I'm on Mac OS, there's a tool called Homebrew that I can install, and that's the fastest way I can think of to kind of install PostgreSQL. And so if I install Homebrew, then I just need to go to the command line and just say brew install PostgreSQL. That's good. I mean, it's a tool. There's one tool for Mac OS. It's a package manager, and it allows me to install different packages that I want. That's good. But on Windows, Homebrew doesn't exist on Windows. So, however, you can just download and run the interactive installer that is officially supported by the Postgres team. So there is that. It's interactive, which kind of makes it a little difficult to, well, it makes it difficult to automate. There are ways that you can automate it, but they're not, how do I say? If there are ways to automate it, but they wouldn't be the same ways to try to automate it on Mac OS. And also on Ubuntu, the popular Linux distro. From the command line, we can just run sudo apt update to make sure that we have all the updated like package registries in our package manager. And then we run sudo apt install PostgreSQL and PostgreSQL contrib. So there's kind of like, on Mac OS, we used Homebrew. On Ubuntu, we used apt-get, and two different package managers on two different systems. And with Mac OS, all I needed to say was, hey, install PostgreSQL. Whereas in Ubuntu, I had to say PostgreSQL and some other package that works, that helps me run Postgres on the Ubuntu operating system. So that's an issue. It's difficult to kind of debug issues across developer machines. So if we're working on a project together and we need to run PostgreSQL because it's our database for our Python project, for instance, our Python web service that we've built, then if my partner is using accidentally installed an older version of Postgres SQL, and I have the newest version of Postgres, and they're experiencing an issue, or I'm experiencing an issue based on a change that was made to the code base or something, it could lead to kind of tracking down different things. Like we could be like spending hours trying to understand like what's going on and where the problem lies. It's also difficult to switch between different application versions. So it's very easy to kind of to what's called like dependency drift on teams, where my developer partner, they again might be on a different version of Postgres than I'm on, and if I want to switch to like their version of Postgres, or if they need to update their version of Postgres to like whatever the latest mine is at, or downgrade to an older version of PostgreSQL, that could be kind of difficult depending on your package manager. It's also difficult to run more than one instance of Postgres on the same machine, just because of how the package managers work across Mac OS and Linux, and especially on Windows as well. And again, it's difficult to automate. And as a developer, we tend to try to, save keystrokes. We try to save the company money on the amount of time we spend doing repetitive things. And if we can't automate some of those repetitive things, like installing software that's needed for our project, that's not a good place to be. So with PostgreSQL and Docker, totally different story. All we need to do is download Docker for desktop and then run a command. We need to do Docker run, and then we're going to put the application in the background. The name of the application is Postgres. It's going to run on a Docker network, which is it's a Docker resource that just allows your Docker applications to talk to one another. And then we're going to pass in some environment variables required for Postgres. So we need the Postgres password to be able to connect to it. We need a PG data location for our Postgres data to live. And then there's a volume. So there's this concept of a volume and Docker. So there's Docker networks. There's also Docker volumes, where when Docker is running on top of a host operating system, a volume or a place to store data for your Docker image. So that way, when you destroy or when you start and destroy your Docker image, especially if it's data related, like storage, like as in like a database, like PostgreSQL, you don't want to have to reseed your database. That could be like costly, or you don't want to lose data. And so one way of accomplishing that is creating a volume on your host machine. And Docker does this automatically for you. So you just specify the location, so the temp directory, the root temp directory, the project name, and then DB is like, it's just a place for me to store my database related data. And then in the then inside the Docker image, anything that's going inside, anything that is changing inside var lib PostgreSQL data, which is this path is where the Postgres data is going to is where the Postgres data typically lives. And so we're kind of, if you could think of it at a super high level, that it's like we're piping any data that is going inside of here is going to go to our host operating system. So like Mac OS or Linux or Windows for that matter. And lastly, we just need to publish a port to run on. So that thing that we talked about a slide ago, that it's difficult to run more than one instance of the same application. Well, with Docker, it's made to be a lot easier to do that. And so port 5432 is the port that Postgres typically runs on. However, I can on my host operating system, I can assign this Docker image or this Docker container to run on a different port. And so right now they're assigned to the same port, but if I wanted to run more than one instance of my Postgres container, I can do it I can change from port 5432 to port 5000 or port 5433. So yeah. And finally, the last part is Postgres 13-Alpine. So I have it highlighted in yellow that this is the image tag and Postgres is the image name. So in Docker Hub, if you were to type in Postgres, you should find a page for the official Postgres Docker image. And if I were to look it up as Postgres, then I'll get like a whole bunch of options to download Postgres. And if I didn't put this tag here, 13-Alpine, if I got rid of the :2, it would just download the latest image for Postgres. So it would be like the Postgres, I think 17 or 16 that's out. I cannot remember. But if my project relies on an earlier version of Postgres, I can just specify the Postgres version that I care about, which is 13, and then -Alpine. Alpine is we talked about how Docker images are really like very lightweight VMs. Well, some Docker images can be kind of bigger than others. And so And so an Alpine image or an image that's tagged as Alpine is kind of is an even slimmer version of a what we call like a base Postgres image. And so, anyways, when we see Alpine, think super lightweight image. So, anyways, I said all this. I kind of gave you a whole overview about like this Docker command, and all you need to do is just copy and paste this and run it, and you're done. So it doesn't matter if you're on Mac OS, you're on Linux, or if you're on Windows. This command should work there as well. So as long as you have Docker for Desktop installed. So this kind of leads to it's easy to distribute containerized applications. You just create a Docker file, and then, or you can, if your program that you've built can do this, there's actually specialized tools out there that even help automate the creation of Docker files themselves. So you just create a Docker file, and then you can build the Docker image based on that Docker file, and then you can push it to Docker Hub, and then from there, like whether it's a cloud environments, like it could pull the Docker image from Docker Hub, or your pair could pull it down from Docker Hub directly. And so Docker as a platform has made it very easy to share and maintain Dockerized or containerized applications. It's also very easy to start, stop, and destroy containerized applications as well. So when we install an application directly on our OS, we have to kind of remember, oh wait, I'm on Mac OS. I'm using Homebrew, and I need to make sure that I run brew services start like Postgres and all, and like. But on Linux, I got to do something else. Like on Linux, there's a different way of doing it there, and it's hard cognitively to remember all the different ways to run software with different tools. And so with Docker, it makes it very easy to kind of standardize around that. So it's also like we demonstrated as stated previously, it's also very easy to switch between supported versions of the containerized application. So we're able to switch between older versions of Postgres very easily, and like we said, we can have multiple versions of Postgres running on our machine. They're just going to be running on different ports. So, and lastly, because this is just a very I'm not going to say it's simple command, but it is a command that will help run Postgres across multiple machines very easily. So since it's just a command line command, it's very easy to automate. So in practice, different people. I know we've been talking quite a bit about software developers, but there's also data scientists who also can make use of Docker, very specifically to run software like Apache Spark, which is a big data analytics engine. It's used to build like recommendation engines. It's used kind of like all over the place. How do I say? Banks use it. Social media platforms use it. And if you've ever heard of Hadoop, Apache Spark kind of grew out of the Hadoop project. Also Python, we talked quite a bit about Python. So there's also Python and NumPy, like that's something data scientists tend to use quite a bit as well. And a data scientist can pull down different versions of Python, and they could run and they can do mathematical queries with NumPy very easily. And then lastly, like another super useful application that data scientists tend to use is Jupyter Notebooks, which is a kind of a collaborative web-based interactive computing platform. So it's a lot of words, but essentially it's kind of like it's like a shareable notebook that allows you to take some of the things that the machine learning models or the things that you're trying to build out and do with graphs and whatnot, and turn that into something that other people can learn from and understand from what you're from the machine learning models that you're trying to build. So yeah, so Jupyter Notebooks, super fantastic tool. Data scientists tend to use quite a bit, and you could use Docker to install Jupyter Notebooks on your host machine. So also, they can share their machine learning models with their colleagues. They could bundle and package their Python project with their TensorFlow model, like all in one place, and they can essentially push it to Docker Hub, and their colleagues can pull it down from there. Or their colleague, if they're using version control like Git, or they're using things like GitHub or GitLab, then they can pull down and just run Docker commands to get the machine learning models from the project source code directly. Yeah, and then finally, deploying their machine learning models to a production environment. So that's an extremely useful use case, since you're using the same tools locally for local development purposes. You're also using in a production environment, which enables application developers, software developers to experiment and to not have to think so much about how the local development environment is so different from the production environment where their application is going to eventually live. So same thing for data scientists. They can experiment and push their machine learning models to a production environment very easily. So I talked quite a bit about this, but as a software developer, you can run web servers like Redis, or I'm sorry, like Nginx. You can run a caching solution like Redis, which is which is a very popular open source caching solution. And so if you have like a Java project, or like a Spring project, or a Python project, and you need to cache, you need to cache your data, you could instead of installing Redis, directly on your host operating system, you can just run it as a Docker image, and and connect to it that way. So MySQL, and one we haven't mentioned before is SonarQube, which is for kind of like code quality analysis. So easily run backing services. Applications on local and remote machines are as close to one and the same as they can be. And then finally, deploying my application in a production environment with a container runtime. So if there's a container runtime like Docker that I can push my application to, then that makes it very easy for me to, debug and handle things locally and remotely. So yeah, so I know we've been talking a lot about deploying to production, and there are a few different tools out there that handle that purpose, and they're all very complex. But the one I'm about to speak to is Kubernetes. And without going too deep into Kubernetes, Kubernetes is just a way for you to manage your containerized application in a production environment. So when your application is deployed to a production environment, your old application needs to come down. But before it can, so that way, when your new application comes up, and you have a load balancer kind of in front of your two applications, you want to make sure that your new application isn't going to like just fall over and fail in production, and people are experiencing 500 errors on your website, or on your mobile service, or the website is starting to lag due to all the traffic that's going out to this new application that has like a memory leak or a bug inside of it. And so, anyways, all these things that you have to think about when it comes to deploying to production, Kubernetes enables you to do those complex things fairly easily. So, yeah, Kubernetes is a tool for kind of managing your containerized applications in production. So to learn more about all the available Dockerized apps from one central place, check out hub.docker.com, hub.docker.com. And then if you'd like to take a look and see kind of to learn more about why Docker is so popular, this is kind of an older article, but it's one that kind of came up, I think this came out in 2018 when this was written, or 2019. But yeah, it kind of goes a bit more into the history of like why Docker became so popular. And then to learn more about Kubernetes, you can take a look at kubernetes.io, docs, concepts overview. What is Kubernetes? Which honestly, I stole some things from that, from this particular post to kind of like help supplement this the slides here. So, or for this presentation, but it's I'm a huge fan of Kubernetes, and there's a lot to learn from there. More complex than what we're talking about today with just an introduction to Docker, but yeah, Kubernetes is there for actually taking Docker to production. So yeah, and now it's time for a small demo. So I'm going to just open up my terminal, and we are going to run a couple of commands. So so what we're going to do is we're going to run PostgreSQL and through Docker, and then we're going to run a PostgreSQL client through Docker that's going to talk to our other Dockerized Postgres application. So in order for two different Docker images or two different Docker containers to like run or to communicate with one another, we need to create a network, a Docker network on the host machine. And so if I type in Docker network ls, this will give me, this will tell me all the different networks that I have available on my machine. So there's the host, and there's, oh, sorry, there's the host, and it has this network ID, and there's a bridge, and it's connected to this network ID. So the thing that we're going to create real quick is a network for our Postgres database to communicate with other applications on. So if we say network create project network, just some name, and then if I go, so it's going to create this ID. So something really neat and interesting about Docker is that for every command that you run with Docker, it will always give you an output. So from a DevOps perspective, it enables it enables you to write automatable, idempotent scripts, and so which makes automation just a lot easier than tools that do not have an idempotent kind of tools that weren't built for idempotency, where for every input you have an output. It just makes it harder to automate. So yeah, so now let's do Docker network ls. So now we have our new project network, which is a bridge. So we could have used the bridge network, but just showing you an example of this, so that way there's no like real magic behind the scenes. So next, I'm just going to copy and paste this, just because this is a lot to type out. This is like one of those things, like you create this once. I did it for this presentation, and then you put it into a bash script or a PowerShell script or some kind of scripting tool, and you don't think about it too much again. So for your purposes, for your project purposes. So we're gonna run it, and so the first time this is run, it's not going to be able to find the image because we didn't install the image locally. And so this Postgres 13 Alpine image is going to be fetched. As you can see, all the numbers and progress stuff that was going by. It's going to be fetched from Docker Hub. and without going into too many details, essentially, there are many layers to a Docker image, and the more layers there are, the less likely you're going to spend downloading a part of that layer that's how do you say, that's because it's a very natural thing for systems to download and pull in Docker images. And if your image has a layer to it that has like lots of data in it, because you can't chop up the amount of data that's that's associated with your image. Like, let's say it's like it's just a really big like machine learning model, like it's like gigabytes big. Well, there's going to be a layer here that's just going to take 2 or 3 minutes to download just that machine learning model part of it. So anyways, yeah, so but because we're just using plain old PostgreSQL with an Alpine image, it flies by pretty quickly. Cool. So so now let's take a look and see with Docker PS. Docker PS is kind of like we run PS locally. You can see all the different things that are running on my machine. Well, Docker has a PS command that tells you all the different programs that are, well, all the different Docker containers that are running at this time. And so what this says is that it has a container ID, it has the image name, and the name of it is Postgres, because that's what we named it. And it's port forwarding. The host machine, 5432, is pointing to the container's exposed 5432 port. And so that's what we've done. And yeah. And so if I wanted to see if this Docker image was available to use, all I need to say is, hey, let's look at the logs. And so I can say Docker logs, and then given the container ID, we can see the logs. So when Postgres first kind of boots up, it's going to run through a bunch of different initialization things. Well, and here's the logs for that. And so it looks like at the bottom down here, the one that matters, or the last message, is that the database system is ready to accept connections. Wonderful. Okay, so now what we want to do is we want to connect directly to our running PostgreSQL image. And so to do that, we tend to use a tool called PSQL, which is a PostgreSQL client that comes with Postgres. And so if I do Docker run -it, which is interactive, -rm, which is short-lived, like I don't want this to live for very long, and I say on this network, on network project network, then, and also I want to use the image Postgres 13 Alpine, just something real quick. It's the same client that, the same PostgreSQL database I'm connecting to, I'm using the same client for. And so if they're both the same version, it just keeps things compatible, and there's like less things to think about. And so, and then I'm going to run a command. I'm going to run the psql command, and I'm going to say .h, which is the host, and I just need to say Postgres, without getting into too many details. But essentially, for one Docker container to connect to another Docker container, it needs to know the host of where this Docker container is like running. So it's not localhost. So if we said localhost here, it's not going to know what localhost is. Instead, there's what's called a DNS entry for Postgres, which Docker automatically does for us because it's the name of our image. So anyways, and so the user is by default Postgres. You can always change that through configuration. And once we hit enter on this, so if we've gotten this far where it's asking for a password, that means we've connected to the machine, or to the local Postgres instance. And now I just need to provide it the password. So originally, when we created this Docker image, or I mean, this Docker container, we set the password to be my secret password. So you're not going to be able to see it just because this is how most this is just how kind of command line tools typically end up working, is that you don't see secure things in plain sight. They're not visible. But now we're in. So this is the Postgres instance that we have installed locally. And because there's no tables, if you do /det, this will display tables. It's just a command to display all the different database tables inside my Postgres instance. And there are none because, well, we haven't created any. But yeah, so anyways, that is my, that's my presentation. So does anybody have any questions?
I think we had a question in the chat about
what
manages CPU resources, the Docker container or the host operating system?
Was that CPU resources? It would be the host operating. So the host operating system actually manages the CPU and memory and such. Docker, there's a way with Docker where if we go up here, we can actually specify through preferences just how much resources we can allocate towards the Docker, how do we say, the Docker for desktop application, like really the Docker runtime has access to. And so this machine that I'm running on has up to 16 gigs of memory. But I wouldn't want to do that because it's going to try to take 16 gigs of memory if I have enough applications running. And so I tend to keep it kind of at 5 gigs and whatnot. And also we can even specify the disk image size as well. So to answer your question, it's the host operating system that's managing the actual CPU and memory usage and disk size and stuff. But we could also use Docker to allocate a certain amount of CPUs. So this isn't I forgot what metric they use for number of CPUs, because it's not like, this is yeah, it's not the number of cores. Maybe it is number of cores. I forgot. With Kubernetes, there's a different metric for how they handle CPUs and memory. But anyways, but on Docker, through Docker for desktop, I believe it's actually cores. So I can say up to 3 cores are dedicated towards Docker resources and such. Yeah.
So I'm actually curious, how can Docker have access to other accelerator cards on the same system? So could you grant it access to GPU resources or something like that?
Yes, I believe you can. Let me see. Yeah, so there are some tools, there are some kind of image processing tools that are containerized and Dockerized that I believe you can. You just need to. I haven't done it myself, but there are ways to do it, so to speak. Let me see.
I know NVIDIA has a tool for their GPUs that allows you to pass them through to any Docker container and give the container full access to any component of the GPU.
Yeah, that sounds right to me. With on Kubernetes, which very kind of way more complex of a system, there are ways that you can have nodes that are specialized nodes where you can run GPU intensive tasks. So but I actually don't believe it has anything to do with Docker. It's more of just how the Kubernetes kubelet agents work and such. But anyways, that's a really good question though. I haven't actually spent too much time doing GPU intensive activities. There there have been people. There have been kind of internet celebrities who, well, developer celebrities who have used Docker to run Google Chrome or Spotify. So instead of like installing and running Google what's it called? Instead of running Google Chrome on your host machine, instead you can actually run Google Chrome through Docker. So there are ways that you do GPU related, like, how do I say, GPU and related things from your host machine through your Dockerized application. So.
Question about containers and direct hardware access as well. Can containers be given exclusive access to SATA drives or network cards?
So technically, yes. So you can create a volume, and that volume, as long as the host operating system mounts that volume, whether it's like a remote volume somewhere, like it could be on a different machine someplace else, as long as it's mounted on your machine, your the Docker runtime will give access to those volumes. What's the word for it? Yeah, so as we showed in kind of, let's go back to iTerm.
Well, actually, TJ, I think I'm not being clear. That really needs to have physical access, not to a volume, but the physical device, the DEV, not the volume. Can a container have access to a device on the host machine?
Yes. So so for instance, if I wanted to do that in here, I just need to let the Docker runtime know to do that. So I have different mounts on my machine, like users, volumes, temp, etc. I believe I can also say like dev as well.
And while you're looking for that, related to that is USB devices like webcams or more exotic USB devices.
Possibly. I haven't done some of these things. I just haven't done it. And these are like really great questions. Yeah. So webcam through Docker. Let's see. Yeah. Stream your video camera or stream video from USB cam in 1 minute with So FFmpeg is a really popular video processing tool. Stream video from USB in 1 minute. Yeah. So
interesting. Cool.
Yeah.
Good. Thanks.
Oh yeah, here it is. Dev video 0. Dev video 0. Yeah. So yeah, it's just mounting a different. If it's mounted on your system, and you give it and Docker for desktop is able to look at this locally. Let's see. Right here. I just need to specify /dev, and I should be able to get access to those flash drives or webcams or such. Yeah. Cool.
But a question in the YouTube chat: can Docker be used with a React app?
Oh yeah. Yes. Yeah. Absolutely. You can package and bundle Node application or Node.js based applications very easily. I mean, when I say React app, I would say that like React, you can once it's all kind of statically compiled into a JS bundle or JavaScript bundle or a public directory, so to speak. It could be added to a static directory to a web server like Nginx or to an Express server, and you can serve up the content that way. Does that answer your question?
I believe so.
Yeah.
I was curious, could you touch on the different types of containers? I know Docker's become popular, but there's also, I want to say, LXC containers as well, and I thought Red Hat had their own solution.
Podman, yeah.
Yep.
So there is something called the OCI, Open Container Interface. Let me see, actually. Open Container Initiative. Nice. And so Docker I didn't really mention this previously. Docker is a I believe originally Docker's a company, but originally that company was well, they spent a lot of their time like working on hosted VM solutions and stuff. Think of like DigitalOcean or like Linode, and then internally Linux containers were how do I say this? Essentially, they pivoted on their major projects around like hosted VM solutions, and completely pivoted towards building a commercially viable container solution. They just called it Docker. So to answer your question, there are different container runtimes like Podman, LX. I believe I've never used LXC, but I believe LXC containers.
Isn't LXC the one that VMware implements by default?
That's a very good question. I think it's actually Canonical that does this one, because I don't know the history behind this one.
I thought it was the default in Proxmox, but I could be mistaken.
I've never heard of it. I apologize. Yeah, I've never heard of it. I haven't heard of Proxmox, sorry. But yeah, I believe Linux containers like LXC was the original, like the what's it called? The Docker the folks at Docker discovered Linux containers, and they built a commercial, like they built all their ideas off off the Linux container concept. So I try not to get too, like, in my mind, it's you can go kind of deep into the lower level details, and I don't, like, as an application developer, I don't spend that much time with like in that low level of like an area such as like the container runtime, because it's not something, like, what's nice about Docker is containers in general, is that you don't have to think too much about like how the kind of the wrapper of a container works. But does that answer your question? Or
yes, thank you.
okay. Yeah, but actually, I'm sorry. I was talking about OCI, so Open Container Initiative. So again, Docker is a company, and so they didn't want to repeat the past mistakes of like relying on a commercial entity to kind of push as disruptive of a technology as like containers to the masses. And so Open Container Initiative kind of builds an interface to these different like container runtimes like Docker, I believe LXC, but especially Podman. And so as long as like Docker adheres to like the OCI kind of interface, then other runtimes can. So for instance, if for Kubernetes, this is actually more of a controversial news. Like Kubernetes and Docker have been so hand in hand, but over time, Kubernetes has been trying to actually pull dependencies away from Docker directly, and instead rely more closely to the OCI like standards. So that way they could swap out people like an IT department, or really a Kubernetes operator or admin, so to speak, can swap out the Docker runtime for the Red Hat Podman container runtime very easily, because maybe one works more favorably for their purposes and such. So yeah, I guess each one of these different container runtimes have like different purposes, but for the most part, like I think they're all just trying to keep it the compatibility to be the same, and I don't think that they have big advantages yet, other than Docker has like all the main features that you would expect from a container runtime. And I think Podman's like 1-in-1 with the same ideas that like Docker has in terms of like all the different features that you would expect from a container runtime. So
a related question: who pays for Docker?
Aha. So for the longest time, Docker was not was I wouldn't say open source, but it was something that was freely used. And so it wasn't until well, so for instance, Docker was paying for the free use of Docker. So when I was pulling down that those images and such, or the Postgres to run locally and such, I'm signed into the Docker Hub. But I'm on the free tier, as you can see. And how Docker has been making money, like to manage all these different servers and all and whatnot, is through their enterprise program. So they recently just changed their pricing structure to limit commercial entities from using the free tier. So instead, if you're if you're a big company and you're using Docker on your projects and stuff, you now have to use the enterprise. You have to get an enterprise license now to use the Docker for desktop. So, but because I'm doing all this for like teaching and like from like a learning perspective, I don't, I'm under the free tier. But yeah, does that answer your question? Basically, Docker has like an enterprise program that like, or enterprise licensing that people have been using for a few years now.
Sure, so. That also ensures that Docker will survive and be maintained, which is great.
Yeah. There's a lot of commercial activity in the kind of the cloud native container space right now, and there's it's a little too big to fail in my opinion, but yeah. Cool. Does anybody else have any other questions? Or
I was kind of wondering the security. So it seems like Docker might provide an additional layer of security. So if you're running a web application, if someone were to get access to that container, is there any way for them to see what's outside of the container, or is that kind of taken care of as part of the I don't remember the terminology there, but I think you see where I'm going with this.
Yeah. So Docker uses semantic versioning, so it has like a kind of like major, minor, and patch releases. And so those patch releases are a lot of times like security updates because there have been ways of kind of escaping the box and seeing the world, I guess, from a hacker perspective. So if you can, and especially because the applications that you're kind of bundling and deploying to Docker Hub or to a Kubernetes environment, if an attacker, a malicious attacker, were to bundle something that knows how to escape from the container, then it could have access to the host system that your Docker runtime is running on. So that is something that has happened, and that is like the biggest security risk of like Docker. But like any hosted system, that's something that's an attack vector that hackers definitely try to penetrate for sure. But yeah, it's happened before. But I would say that's something that the Docker security team has definitely been trying to reduce the chances of that happening. So that's why it's always important to try to maintain, try to keep up with the updates that in a production environment. So oftentimes these systems like Kubernetes or like any other or these operating systems that like our applications run on, like there's so many different moving pieces and at scale that can be very difficult to maintain. And so so essentially you don't want to stay too far behind on security updates and minor releases and such with Docker. So
I think we've got time for maybe one more question, and then we can wrap up.
Sure.
Any more questions?
Awesome. Well,
Well,
thank you, friends. I appreciate you having me, and please feel free to reach out if you have any other questions on the side or want to learn more about Docker and Kubernetes for that matter. Kind of an advanced like part 2 kind of conversation. Let me know. So thanks again.
thank you very much, TJ. And just one announcement before we go. Our next month's meeting, we think will probably be, we don't have the final details yet, but we have a speaker lined up and we think it'll be that last week of March. So it will not be the normal 3rd week, but rather the 4th week of March. And we intend for that to be an in-person meeting where we would have, food and everything, but we have to get the date finalized for that. That's what we're thinking at the moment. So with that, thank you everybody for attending. Thank you again, TJ, for your presentation, and I hope everybody has a great night. Thank you, everybody.